So good morning, good afternoon, good evening, depending on where you are in the world. Thank you for joining our seminar in the Tiered Preparedness and Response series. This one is around the protection of sensitive resources, and we'll get into what that's all about, some of the issues surrounding that in just a moment. So welcome, thanks for joining, and I hope you enjoyed. Just a couple of pieces of admin. If you've got any questions, then you can put those into the chat and I'll either pick them up as we go or grab those at the end. And I think everyone's muted, but just for good order, if you could just keep cameras off and muted to preserve bandwidth, we'll get going. Okay, so just by way of introduction, my name is Dave Rouse. I'm the Crisis and Incident Management Lead for Oil Spill Response Limited. I've worked all over the world, responded to lots of spills, delivered lots of consulting and training projects for various energy companies, governments and similar. And I was one of the co-authors of the Good Practice Guide for Net Environmental Benefit Analysis, which features a little bit in this presentation later on. So my contact details are on the screen. If there's anything that you want to follow up with me separately, please use those. And obviously the OSRL details are there as well. So what I'm going to talk about over the next 30 minutes or so is the protection of sensitive resources and discuss some of the principles around that and some of the issues. So, aim. We seek to protect sensitive resources. The reason why we do that is, I think, self-evident. So explaining why I'm not going to spend a lot of time on, but I am going to talk about how we do it and what we do. So the types of tools that are available to us, how we select the right ones and how we would deploy them. So just by way of some context, this is one of a series of seminars that OSRL is putting on for tiered preparedness and response. So just as a reminder, tiered preparedness and response is the internationally recognised planning approach used to define and structure the levels of response capabilities, plan to have the appropriate resources available to be mobilised, and enable responses to escalate to deal with a spill of any magnitude at all. So I think the first point to make is prevention is better than cure. We would prefer not to have a spill in the first place, but when we talk about response, it's about what do we do for an event that we hope never occurs. Second point is tiered preparedness and response is nothing new. The model has been around for many years, and it was refined most recently after the Deepwater Horizon incident with the joint industry project to refresh industry's good practice guides. And one of the things that stressed at that point was we disassociate the level of the spill, the size of the spill from the tier levels that we assign. We don't try and plan and say, well, a 50,000 gallon spill will be a tier 2 or a tier 3 or a tier 1. That's not really part of it. This is really just a planning tool to illustrate what capability do we need, how much do we need, and when do we need it based on risk. When we talk about capabilities, we're talking about the combination of expertise, competence, we call it responders here, but it's really expertise. Whatever equipment that we need in a response, we know booms and skimmers and vessels and capping stacks and all sorts of things like that make up the equipment. We need the expertise to be able to use that equipment, but we also need additional support, and that could be the supporting infrastructure, the supporting logistics, any of those other underlying things that are required in order to deliver a capability. And the graphic shows a segment of the tiered preparedness and response wheel with the definition of tier 1, which is resources which are required immediately to handle a local spill or provide an initial response. Tier 2, which is the national or regional resources needed to supplement a tier 1 response. And tier 3, which is the global international resources for spills that require substantial additional response, additional capability, or very, very specialist resources which are not pragmatic, not sensible to try and recreate in lots of small places. So This is all refresher stuff. If you've tuned into any of our other seminars, you will have seen these slides already. Just a reminder of the tiered preparedness and response framework. It defines 15 separate capabilities. So each wedge on this wheel shows a type of response capability, and the tier represents the capacity required to respond to a spill for a specific facility or region. When we say accessible, we don't mean that this is on-site resources. As we just said, tier 1 are generally going to be located on site, but tier 2 and tier 3 resources will be off-site, but we know how we would seek to cascade those in. Today, we are talking about this one, protection of sensitive resources. I was trying to come up with a better definition than this for you, but really it is quite self-explanatory. The definition of protection of sensitive resources is the protection of specific sensitive resources from contact with oil. So just to elaborate slightly on that, when we talk about sensitive resources or sensitivities, we're talking about anything which could be affected from contact with spilled hydrocarbons or the knock-on effect of spilled hydrocarbons. So why do we seek to protect sensitive resources? I think goes without saying. So we'll spend more time on what we can do and how do we do it. So hopefully the animation will work on this slide. So start of all, protection of sensitive resources on the tier preparedness response framework is slightly unusual in that it spans quite a broad spectrum, and we look at it from two perspectives. We look at a macro perspective and we look at a micro perspective. So at the macro perspective, this is the ability to look at the entire environment that may be affected by a spill, to be able to identify and prioritize the sensitive resources in that environment, and then use that information to inform the right response strategy to put into place, the right tools to deploy and the way to deploy them. So that's at a macro level. We're looking at a large geographical area or a geographical area commensurate to the size of the spill based on what could be affected. At a micro level is when we zoom right in, and this is what some people assume we mean by protection of sensitive resources. They're always thinking booms on beaches. That is part of it. That's the micro level where we zoom right in. And we're talking about how do we protect specific sensitive resources? What tools do we need to do to protect, say, a fish farm or a water intake or a particular estuary? So we're going to get into both of those in a bit more detail, but I just wanted to give the big picture context and explain, there is a spectrum from a macro to a micro perspective on how do we approach this. And this is a little bit different from some of the other parts of the tier preparedness framework. Right, so macro perspective. To help illustrate this, we'll take this approach first. Here we've got a hypothetical location. We have a spill that occurs a little way offshore. And as you can see, there are many different sensitivities in this area denoted by those icons, which could potentially be impacted by the oil. And we would, in a real event, have surveillance and modelling carried out to try and understand and refine our understanding a little bit more about what exactly could be impacted and when. But this is the big picture. We've got a spill, we've got lots of sensitive resources, and we're talking things here like fish spawning areas. It could be deep sea squid, it could be dolphins or whales or rays, it can be lobster. So we've got a whole load of ecological receptors. It could be turtle nesting beaches. It could be, we've got on here albatross and pelican habitats. It could be the human use sensitivity. So it could be commercial fishing or leisure fishing. Marinas or amenity beaches, can be commercial ports, could be industrial facilities. And of course, there's always, in a response, as we've seen many times, it can have a deterring effect on things like tourism. So in a particularly, in an area that relies on tourism for its economy, if there is a spill in that area, the knock-on effects on local communities are felt far back in the supply chain for not only fishermen and those who rely on the area for providing hotels and restaurants, but the hotels, the restaurants, and then the knock-on supply chain of those as well. So it goes fairly deep. And then we've got historical and cultural sensitivities, which could be locations with particular historical significance. It could be archaeological sites or sacred areas belonging to indigenous populations. So generally speaking, we would classify ecological, human use, and historical cultural sensitivities as the categories. So clearly those are all very important, but how do you protect them, and how do you decide how to use the resources that you have is what we're going to get into next. So how can you protect the sensitive resources? There are many tools in the toolbox in order to combat an oil spill, and we're talking about things like booms, skimmers, and dispersants. But anyone on the call who's a responder, or a planner will know it takes time for all of these resources to be mobilized, by which time the oil will have spread. So there are some questions that we need to answer. So the first one is, how do we prioritize the sensitivities to protect? The second is, how do we select the right response techniques and the right combination of those in order to do so? And then how do we deploy them in the way which has the greatest overall impact, the greatest mitigation effect on the spill? So we're still at this macro level, and at a macro level, we would use the NEBA process, which you may be familiar with. NEBA stands for Net Environmental Benefit Analysis. And, this may be revision for some, but the NEBA process is used in every stage of oil spill preparedness and response, before, during, and after a spill. It aims to decrease the overall effect of oil on the ecological, the human use, and the cultural sensitivities, whilst achieving an acceptable level of cleanup. And the process is intended to help facilitate discussion, to gain agreement between stakeholders. And it's really all about, how do we balance quite complex trade-offs often? So, for example, how do we prioritize between ecological, economic, and cultural sensitivities? How do we balance the benefits and the drawbacks of the different response techniques available to us in order to achieve a standard of cleanup that is acceptable to stakeholders? And of course, the aim is to mitigate the overall impact of the spill on the environment. So 4 stages to the NEBA process. You can see the guidance and information on the screen. Stage 1 is compile and evaluate data. Stage 2 is predict outcomes. Stage 3 is balance trade-offs, and stage 4 is bringing that all together and selecting the best options. So ideally, this process is followed before a spill, and it's built into the contingency plans that exist and the sensitivity maps that exist. So if a spill happens, we're not having to spend a lot of time getting engagement and stakeholder buy-in and try and have some of these really complicated discussions that rely on data in the heat of the moment when it's very difficult to do so. Ideally, we would have this done beforehand. The output of NEBA, the culmination of stage 4, where we select the best options, is the response strategy. So how are we going to deploy the resources that we have to protect the sensitivities as best we can? So, talking about doing this beforehand, and it's very complicated to do during a response, or it can be, the way that you conduct a net environmental benefit analysis, the way you conduct a NEBA, depends on a number of factors. So first of all, are we in the planning phase? Do we have the luxury of time to do it and to get the data that we need, to get the workshops organised, to get the stakeholders together? Or are we operating now in an area where we didn't have a contingency plan, or the plan is out of date, the sensitivities have changed, and we're in response mode and we have to do it very quickly? The nature of the scenario or the incident will have a bearing on the way that we conduct a NEBA. And one of those factors would be how long do we anticipate the incident lasting? So, for example, in a small spill with few sensitivities, few stakeholders, not too complex, you would probably rely on an experienced responder to be able to carry out an abbreviated NEBA process very quickly, and then they would go on and deploy resources. Whereas in a more complex spill, many sensitivities, multiple stakeholders, lots of competing priorities, a long duration event, a much more collaborative, systematic, and data-driven approach would be appropriate. So the way that we conduct a NEBA is on a spectrum. There's different ways of doing it depending on where we are. But I did want to highlight for you the SEMA tool. So SEMA is the Spill Impact Mitigation Assessment tool, and that's one methodology that's available to us to help conduct a NEBA, particularly for the more complex type of incidents. So on the screen, you've got a picture, which is a screen grab from a spreadsheet. It's reasonably self-explanatory with the resource compartments down the left, and then a way of carrying out an evaluation of the different response techniques available to us and how they play off against each other and benefit or don't benefit certain receptors. So at the end of this presentation, there's a link to the SEMA Good Practice Guide, which goes into this in the appropriate detail. There simply isn't time right now to go into the full step-by-step for it, but it's a couple of things I did want to highlight. So first of all, it's a mechanism for comparing the relative sensitivity of resources and the relative feasibility of response options. Everything we do in a SEMA is relative to the scenario that we're talking about. It's not a mathematical model, but it is designed to be a tool that gets stakeholders talking, supports consultation, is flexible to the spill, but is very, very transparent about what's going on. And it really helps to facilitate conversation around things which are not easy or straightforward to compare. So, for example, there's that question of, if we have limited resources, is it more important to protect a turtle nesting site or a site of historical cultural significance? So, detailed methodology shown here is targeted towards the larger, higher consequence, more complicated spills, but it's just one way of carrying out a NEBA. So I'm flying through this at some pace, and we can, if there's interest, let us know. We can run more detailed seminars on NEBA and SEMA. But really what NEBA allows us to do is to answer these questions. How do we prioritise the sensitivities to protect? How do we select the right response techniques to do so? And how do we deploy them in the way which has the greatest overall impact? Combine that up together, that's our response strategy. So if we go back to our spill scenario here, the response strategy is the combination of different techniques used in the event of a spill. The way in which they're utilised from the source of the spill to the shoreline, we often call the cone of response. And that's talking about zoning of different response techniques at different points of the spill at a point in time, which allows the most effective overall strategy to be developed. And that's based on or informed by NEBA and SEMA. So one thing to say, a response strategy will evolve over the course of the spill. And as we get into it, so the first part is source control. This is controlling or stopping the release. So if we're talking about a well control incident, this would be well intervention. It could be subsea dispersant. It could be relief well going on in this part of the cone, this zone. If it's a vessel, then it could be salvage actions, and it could be lightering type interventions going on there. The next part of the cone, as we work our way outwards, is the response nearest the source. So typically we might see this as dispersant application by vessel or by aircraft. Then as we work our way outwards in the offshore segment, the next part, we might be talking containment recovery with booms and skimmers. If the conditions and the regulatory environment is right, then it might be in situ burning. And then as we come towards the near shore, we're looking at containment and recovery of free floating patches of oil, so very targeted work there using booms and skimmers. And as we come onto the shoreline, we're talking about the shoreline response program, which constitutes or which includes Scat. It includes shoreline protection, and it includes shoreline cleanup. And then the last part, which will set the scene for the next part of the presentation, is the very targeted protection of very specific sensitivities. So where we know on that macro picture, lots of sensitivities, our NEBA-SEMA process has allowed us to say, look, these ones here that we've identified with the targets are the ones that we must prioritise the protection of. So this is where we get into the micro end of the spectrum that I was talking about. This is site level. This is implementing techniques such as deflection or collection booming on a beach, which we'll give you some examples of next. So So this is just the process. Once we've identified a specific site, we zoom right in on the diagram here. We've picked this particular site. What's the process for actually then developing a micro level strategy or tactics for protecting that sensitivity? So we've identified the site. We'll carry out a pre-shoreline impact Scat survey. So before the oil, whilst the oil is still offshore, moving towards the coast here, we'll carry out a Scat survey, which is the shoreline cleanup assessment technique. And that's where we'll go out, we'll survey what the conditions are, what the potential oiling could be, and what cleanup techniques will be allowed. And this is carried out by a stakeholder group that gets agreement from all the relevant parties. We will seek to clean any litter or debris from the site because it's much easier to do it whilst it's pre-oiled and much less waste is generated. And then we will be looking at that site, carrying out, some pre-planning about what exactly will we do on this particular site in order to protect that particular resource. And then we will bring the resources in and we'll implement that technique. And then once the oil does start to impact, we'll be monitoring and evaluating how effective was that protection measure that we put in place and what adjustments do we need to make sure that it continues to do its job and protect that particular sensitivity for as long as it is at risk of being oiled. So we're into the micro level, some pictures now to illustrate some examples of what I'm talking about here. So this is shoreline protection booming. It's a double exclusion boom that you've got here running between the two islands there. And it's looking to protect the sensitivities on the right-hand side of the picture from the oil moving in from the left. So we've got some boom, we've got some absorbent boom, which would seek to absorb some of the oil. And there's a vessel there that's tending and keeping attention to this boom, because obviously in a moving environment, in the dynamic environment that we can see here, you need to keep checking the anchors. You need to check that the boom is still performing as it should do. Sometimes there's some adjustments that need to be made. And this isn't a set and forget kind of technique. It does need attention from responders to make sure that it continues to be effective. Another graphical example here. So this is a fixed diversion boom. So the oil is traveling with the wind and current and is diverted away from a sensitivity on the right down to a location further down the coast, which would be less sensitive. So you would generally find a fixed diversion boom where the anchors are fixed and the boom is pre-positioned in areas where you could anticipate there might be a spill. It might be near, oil operations, and where there are very highly sensitive receptors that need protection very, very quickly. So this requires some pre-planning and pre-positioning of equipment and having responders ready and trained to deploy it very, very quickly. Just another example of shoreline protection booming. So this is a live protection boom. This would be seen not necessarily in an environment like we saw before, where we can anticipate the spill is going to happen and we need to protect this particular resource. This is more dynamic than that, but you can see that it's fairly resource intensive, but it can be done in a way that's fairly effective at protecting those sensitivities on the coastline there. Okay, next one. I've just lost my notes, I think. I don't know what's going on. Okay, so this is a shoreline entrapment boom. So this is trapping the oil as it comes from the top of the screen, moving towards the bottom, collecting it there and skimming it up using a boom that's anchored on the shore and is tended to by a vessel offshore. So lots of different ways of achieving this, and we've zoomed right into how would you do it on a coastline. Another couple of examples. These ones are from real incidents. This is protection of a fish farm during the Exxon Valdez. So another example of how we would protect that particular sensitivity from oil floating on the surface. I think this one is from the Deepwater Horizon incident. So that again is another fish farm, and the booms there are seeking to protect the free floating oil. We're going to come back to Deepwater Horizon momentarily. This one is containment booming from a barge that sank and released its contents. So this is trying to keep the contents away from sensitivities outside of the sinking there. And we're back to the Barrier Islands in Deepwater Horizon. And what I wanted to try and emphasize here was that what we're seeing here with the shoreline booming, the protection booming, this is a sharpshooter technique. What was seen to happen for lots of fairly political reasons during Deepwater Horizon was that parishes wanted to boom off huge swathes of the coastline. They wanted to surround and encircle every single island with all of this boom. And as I said before, this isn't something you can just set and leave and think it will be effective. It needs constant work and tending. And there were many miles of boom deployed, but not enough people with the expertise to go and deploy it properly, but also tend to it whilst it was out. And so here you can see that some of the islands have been boomed off and it all looks good. But this is what happens when it goes wrong, when it's not tended to, when hurricane comes through or high winds or high waves come through, and this is boom that had blown up onto the beach, had failed totally, and the mangroves there were oiled anyway. So it's really about knowing, when we go back to the big picture, what is important to prioritise and how do we direct our resources to be able to do it in a really effective way. Right, I'm coming to the conclusion. I think I've got about 3 minutes left, so just a couple of other points to make. The tools available to us, I've zoomed right in on shoreline booming and shoreline protection. There are many tools available to us to protect sensitive resources, and there's a whole list of them on the screen. And it's many of the other response techniques that we talked about on the tier preparedness framework. And just so there's time to answer a couple of the questions which I saw pop up in the chat, I'll just bring it to a conclusion fairly quickly. So, real whistle-stop tour, 30 minutes to talk about a massive subject, but hopefully I've managed to convey a few things for you. First of all, there's two perspectives to look at protection of sensitive resources, two lenses to look at it through. The macro lens, looking at the entire environment that may be affected by a spill and how to prioritise resources within it. And then the micro lens, where we zoom right in and say, how do we protect a particular resource, and what capability, people, equipment, and other resources do we need to be able to do it? There are many tools available to us. They each come with benefits and drawbacks, and there are rarely enough. It's important to prioritise, but that can be complex. But the NEBA and CEMA process, or the NEBA process and the CEMA application of it, is there to help. It's there to help engage stakeholders to develop a really effective response strategy. As I said at the start, there's plenty of detailed information out there, and we'll happily run more detailed seminars on the NEBA CEMA process if that's helpful and there's interest, so let us know. But this is where I would direct you to the IPECA website, link on the screen. You'll get this afterwards, and when the presentation sent you anyway. Has got the good practice guidance for NEBA, for CEMA, and it's got it in a couple of ways. There's a really neat animation, there's a high level glance scan document, and then there's the more detailed good practice guides there, which goes into how you actually implement the process and how to do it in more detail. So that was it. There were a couple of questions pop up in the chat, and if you've got any now would be a good time. Let me just come to those that were shared earlier. So we've got one talking about the sensitivity area map. So that was one of the earlier slides that I showed. Would be a worst case scenario, or from our experience, could there be such a busy sensitive area to protect in a real incident? Thanks, Tanya, for the question. So it was a fictional scenario there that I was deliberately quite prolific on just loading up with sensitivities. But it is not uncommon to find in many parts of the world where the energy industry operates that number of sensitivities. Now, what I didn't try and show there was, where we had some of the amenity beaches. There might be that those are particularly sensitive, particularly important to the tourism industry, and so they are relatively high in importance compared to others. Or it could be that the whole coast is amenity and tourist oriented, in which case are they relatively so important. So really the graphic was there to show what it could look like. It is not terribly unrealistic, but it wasn't inspired by a particular place. I had no particular place in mind. I hope that answers your question, Tanya, and please do follow up if you want to, if I haven't done so. Great, thanks. Right, Andrew, just give me a moment to read this. Two observations. One, in the UK would expect the relevant environment group to be significantly involved in the prioritisation process. Agree. 2, in terms of Deepwater Horizon, BP's reputation and share price was also a sensitive resource. Inevitably, there will be a conflict between what is a priority determined by science and what is a priority determined by reputation, e.g. protecting emotive species. Yes, agree. From experience of responding in the incident, the ongoing survival of the company was clearly important in order to fund the response. Point 1. Point 2, it genuinely was driven, I think, by what is the correct thing to do, what is the correct response technique, and we throw every single resource in the world at it in order to prevent the oil from, stop the source, prevent the oil from hitting the shoreline and damaging the economy, damaging the beaches, damaging the marshlands, the wetlands, all of the sensitive resources there. So the conflict between the priority of, what is determined by science and what is determined by reputation, I think more generally we see that play out as what is determined by politics versus what is determined by science. So back to the Deepwater Horizon example of where we boomed around lots of islands. That was not a scientifically, technically good response thing necessarily to do. Was that boom going to be effective in all those cases? No, experienced responders knew it wouldn't be. However, there were reasons that BP would have agreed to do that. There was a lot of political pressure, and one of the metrics which the states were particularly interested in, and the parishes within the states, was how many miles of boom have you deployed? And that was, how effective is the response being? Now, that's not a really good metric to use, but that was what was being used. There was a lot of political pressure to get lots of stuff out there. Responders would know, okay, some of this is not the most effective use of resources, but we were in a response where the resource constraint went away fairly quickly. Every piece of boom, every bit of dispersant, everything in the world went to the Gulf of Mexico near enough. And so that resource constraint wasn't there. But I totally agree with you that there is often a conflict between what's the technically right answer and then what's the politically or other driven answers that compete, and how do we keep everything working and keep everything happy. It's very few spills that I've responded to where politics are not a factor on some level at all. So yeah, I appreciate those are observations rather than questions, but I did want to respond to those. Thank you. Okay, if there's any other questions, I appreciate I'm a few minutes over now. Please drop them into the chat and I'll stay on the line for a few minutes. I think people will probably start dropping off soon. But just in closing, I just want to say thank you very much for your time. You'll get copies of this afterwards, as I've said, some details on the screen about how to contact us. And if there are subjects that you'd like us to go into in any more detail, whether they're tier preparedness and response or other things, do let us know. We're very, very happy to do it. And it's great to engage with you. Thank you very much.